Hi guys, and welcome to Arduino Science Fun. What we will talk about today will be how to create an external voltage reference for this analog input that we have in our Arduino board. So why it is important to have an external voltage reference? So when we have some device, like for example a sensor for my helium water balloon, I will use gas sensors which will provide some output voltage to be measured, so analog voltage. And we have this sensor, we will actually connect this output to one of the analog inputs. How does Arduino measure this analog input, what we receive? It will get back a number between 0 and 1023. Okay, this means that there are 1024 steps, let's say. So this voltage will be decoded in a number which has a resolution of, let's say, 1024 steps. Why 1024? Because this is equivalent to 2 to the power of 10, meaning that this converter from this analog to a number, which is actually called analog digital converter, has 10 bits. So this is the way, for example, this Arduino Uno board will deal with analog input. So how to retrieve then the voltage, the actual voltage in volt that we have as output from the sensor? So we need to know what is the end of the scale. So this 1023, which is just a number, to which voltage corresponds? So this is the problem of the reference voltage. So Arduino itself has several built-in reference voltage, which could be like, for example, the 5 volt, which is the input that it gets when we connect this to the USB port from the USB. So basically it means that 0 is 0 volts and 1023 is 5 volts. Okay, so I just have to scale up this. I can choose different voltage references inside Arduino itself, like for example the 3.3 volt or 1.1 volt, but there might be quite some oscillations. For example, for the USB, this USB, instead of being 5 volt, it could be like 4.8 volt. But how can I know it? So this is the importance of having an voltage reference which is external, and we can provide Arduino with this external and super stable, or at least very stable voltage references, so that we can know exactly what is 1023 correspond in voltage and have a reliable measurement of the voltage coming out from our sensor. So let's have a look how we can do this. So let's come to the circuit. So we said we have our Zener diode. We can represent like this, LM4040. We can connect this to ground from one side, and we need to connect to the V-in of the Arduino board, which is actually the power supply of the Arduino board, through a resistance of a certain value R to limit the current flowing through it. Here I can pick up my reference voltage, which I said before we took the version that provides 4.096 volts. Okay, this can reach accuracy of 0.2%, so it's quite accurate. How do we calculate the resistance R needed to make all the system working? So there is some more information of the circuit I need to know. For example, the reference analog reference input resistance, which in the case of the Arduino board is 32K. So I can draw it again here, which would be something like to ground also. And this is 32K. Okay, I need to know the input voltage here. So in my case, it's 9 volts. I will use a battery of 9 volts connected here to the Arduino, but you can use anything from 5 volts to 12 volts. We need to know the current needed, the operative current needed to the LM4040. So we go to the datasheet and we have a look at the minimum current to have this LM4040 working as required is 70 microamp. So in order to be safe, let's say that we want 3 times this current to flow, since the maximum current is 50 milliamp, which is pretty high with respect to 70 microamp. So this means that we want to have a current through the LM4040 of 0.2 milliamp, more or less. So from this info, we can now solve for R. So first of all, we can know the current flowing through the reference, the A reference pin. So EAREF is basically the Vref divided by the 32K. So if we use this value, 4.096, we'll got something like 0.128 milliamp. Great. What is now the current flowing through R? Is this one plus this one, so the sum of these two, which is 0.328 milliamp. Okay, now with Ohm law, I can calculate the value of R as basically V in minus Vref divided by this IR, so this 0.328 milliamp, which turns out to be something like 27K. So I now know how can I pick up the resistance value in order to have this system working and to provide the reference voltage needed. We will have a look in the next video how to use these devices to sample, to measure some voltage from some analog voltage from a sensors, like for example a gas sensor. In Arduino, so I will show you the sketch and all the connections and so on. I hope this was clear how to deal with these external voltage references. So please follow my Twitter if you want to be updated on the project on the helium weather balloon at FanArduino, or have a look to my previous video in the Arduino Science Fun YouTube channel. Bye!